Hey guys, I hope you are doing fine. Today we have some interesting stuff to talk about. Our discussion on the tractor. We looked at the strokes, the two-stroke and the four-stroke. Now we want to look at when the engine does the strokes, how the energy is utilized and how the energy flows in the tractor, and generally how the tractor works. So that is what we want to look at today, the tractor systems. And normally the tractor system will have these items listed here: the fuel system, electrical, ignition, cooling, and the power transmission system. So for today we are going to look at the first four, and then in our next lesson we'll look at the power transmission system. Now what happens? Let us look at first the fuel system. Now for the fuel system, it is normally categorized depending on the fuel. Remember, we are talking about diesel engines and petrol engines, and in that, if it is a petrol engine, therefore the fuel system will be a petrol fuel system. If it is a diesel engine, then the fuel system will be a diesel fuel system. So how do they look like and how do they operate? That is what we want to look at now. First, the petrol fuel system. This one consists of the fuel tank, and of course we know that is where the fuel will be stored. We have the filters, the fuel filters, and this one will remove the foreign particles from the fuel. We have the carburetor and the functions of the carburetor. Remember, we have normal equations that come as the functions of the carburetor. One, to atomize the fuel into spray. Remember, the fuel is in liquid state once it is in the tank, but for it to burn, it has to be converted into sprays or air, so it becomes gas. That's why we call it gas. So in that case, we'll have atomization of the fuel into spray. It becomes in gaseous stage, and then also it introduces fuel and air mixture into the engine. Remember, the air and fuel mixture will mix into the carburetor, and therefore it will be introduced into the engine for burning. And then it also regulates the air and fuel into suitable proportions so that we have maximum burning. So the carburetor will have those three functions. Apart from the carburetor, the petrol system also has a fuel pump. This one will pump the fuel into the carburetor or force the fuel into the carburetor for the above things to happen, and also the delivery pipes that will connect the carburetor to the rest of the devices that will facilitate the flow of fuel. Now that is how it looks like. We look at the first thing. This is air comes in, this is the air filter, then it comes here to the carburetor. So you can see the connection. The air comes from this direction into the carburetor, and then the fuel comes from this direction into the the carburetor. Remember, what brings this is a force by the fuel pump. The fuel pump will make sure that it forces the fuel from this fuel tank. As it flows here, it comes into the fuel filter. It is filtered to remove foreign materials. Then the material will move, the fuel will move without the foreign materials into the fuel pump, and then the fuel pump will push it or force it into the carburetor. Now the carburetor will mix air and fuel in the right proportions to have this, what we call air and fuel mixture, and now it will come into the cylinder where we are having now combustion, the strokes. So that is simply how this structure or this petrol system will work. Now the second one is the diesel fuel system, and this one of course consists of the storage tank. We also have injector pump, and this one is what now replaces the carburetor for the diesel system. Now the fuel injector pump will pump or will push the diesel into the injector nozzles, and thereafter it also breaks into fine sprays. It converts the liquid diesel into sprays or fumes. Now apart from that, we also have fuel filters, of course, to remove foreign materials from the fuel, and there also we have the delivery pipes to connect to various devices to bring about the flow of fuel. Now this is how it looks like. We start from here, the fuel tank. The fuel tank is here. Fuel is normally fed here, and now it is fed up into the fuel filter. We have a feed pump that pushes the fuel from the tank to the fuel filter, and then after that it is still pushed into the injector pump, and the injector pump will inject this fuel into the burning chamber where we are having the strokes, and the air will get in through this the same locality. We have the inlet valve, the engine cylinder, the piston. Now this is inside the piston, so this is how the fuel will come. And now after that we are having exhaust, so we will have the fuel that has been burnt now to produce exhaust fumes will come out through the outlet or the exhaust valve, and therefore it will come out through the exhauster. So that is simply how the diesel engine will the diesel fuel system will look like. Now apart from that, we also have the electrical system, and this one consists of the battery. We know the battery, and the battery plays a very important role in converting the energy into electrical energy, that is chemical energy into mechanical energy. Remember, the battery has an electrolyte, and an electrolyte is a chemical, and this one is what now is converted to produce electrical energy. And then also it also stores what we call electrical energy produced by running. So as the engine runs, it will produce power, and the power will be stored by the battery. So as the tractor moves, it will produce power that will be stored for use later inside the battery. So converting the energy, chemical energy, into electrical energy, and also storing the energy, electrical energy produced by the running of the engine. Apart from the battery, we also have the ignition circuit, and this one provides electrical required by the spark plugs. And in this case, we are talking about ignition to start up the system as the starter. And then also we have the generator circuit. This one provides electrical current that starts the engine. And then we also have the lighting system. Of course, electrical circuit, or the electrical system, the lighting circuit. Remember, the tractor will have the headlamps and the hind lamps, and it also has indicators and so on. So this one is what will be brought about by the lighting circuit. And lastly is the starter motor, and this one is to start the engine. The engine, for the engine to start running, we need the starter motor, which is normally part in the electrical system. Now the electrical system, apart from that, we'll also have the ignition system, and the ignition system will consist of the ignition, and this one change the low voltage from the battery to high voltage. Remember, the battery will only produce 12 volts, and these 12 volts are not enough for ignition, and therefore the ignition part of the ignition system will convert the 12 volts into about 6,000 volts, and this one is what will be required to produce the sparks at the spark plug for the starting of the tractor. And then we also have the condenser. The condenser will absorb self-induced currents in the primary circuits, and it will also store for a short time, that is the it will store the energy, electrical energy, for a short time, and also passes the electrical current to the distributors. So once the current has started flowing, we have excess that will be bring about maybe short circuiting. So the condenser will absorb most of this to ensure that we don't have short circuiting, and it will also store the current for a short time, and lastly it will pass the electrical current into the distributors for the current to continuously flow. So into the distributor, it will distribute the high voltage current to the spark plugs. Remember, we have several spark plugs, and these plugs will ensure that there is sparking at every spark plug for the power stroke. So in this case, the distributor will ensure that the high voltage is distributed across all the spark plugs. And then lastly is the contact breaker, and this one interrupts the normal flow of current in the primary circuit. That if the current is flowing continuously, now we don't want it to flow normally because we want to convert the voltage into high. Therefore it will interrupt the normal flow to bring about the ignition flow. Now this is the structure of the ignition system, and as you can see, we have these parts here. We have the spark plugs, we have the battery here. So we will have this is the ignition switch, and in the ignition switch you can see how it is flowing. That is how it will flow, like that. Then it gets to the rotor, then all the way to the distributor, and you see the distributor will be able to circulate across all the sparks. So this is what is happening. The battery flows in like that, and then it comes here. This is the ignition coil, and now it will to the rotor, and then now we come here to the distributor housing, and then now after that the distributor cap, and then this one, the distributor cap, will do what? Will distribute this high voltage that has been converted by this ignition coil, and therefore each spark plug will produce sparks depending on the flow of the cycles. So that is the ignition. Now the ignition process, this is how it will occur. We start from the ignition key. This is the ignition key. We'll have ignition, and now the current will start flowing from this point. This one is the circuits, the primary and secondary circuits. Now it will flow like that, and now we are having the flow like that here, and this is what is happening. As it flows, it comes to bring about ignition from this point, the first spark plug, the second spark plug, the third and the fourth, and therefore ignition will occur that way. So that is about the ignition system. Now what about the cooling system? The cooling system are also divided into two, that is the air cooled system and the water cooled system, and this one is depending on the size of the engine. The smaller ones have air cooled systems, and the bigger ones have water cooled systems. Now what about the air cooled system? These ones are cooled by use of air, and they are very simple in constructions. They only have fins and fan blades which consist of circulation, which assist in circulation. They are light in weight, for they do not have radiators and water jackets, so they're very light. And these ones will be found in machines like the generators, small generators. We also have the power source. We also have some other parts like mowers and so on. So these ones will only have the fins, and also the fan blades. The fan blades will rotate to cool the air, so that the air comes in when it is cold, and the fins will distribute the air inside the engine, and therefore it will be cooled. Some of the limitations of the air cooled system is that they get hot so quickly because there is no continuous flow of air in there, and also they use, and in that case they will use a lot of heavy lubricating oil, and also the cooling is not adequate under conditions, especially when carrying heavy loads. So you realize that it will not cool effectively, and that it is prone to maybe sometimes burning and so on. So that is the air cooled system. What about the water cooled system? This one is complex, and it has several parts. We have the radiator. This is where we introduce the water, cooling it. We have the water jackets. These ones distribute the water within the whole engine, and also we have the hoses. These are the pipes that will make sure that the water flows from the radiator all the way. And then also we have the water pump. This one is to force the water from the radiator to all the parts that the engine might get hot and therefore cool it. The thermostat is to detect and correct the temperatures changes. It detects temperature changes and therefore brings about a cooling mechanism. Then we have the fanning mechanism. The fanning mechanism, we have a fan that will rotate to cool the water once it has been it has cooled the engine and it is now warm or hot. The fanning mechanism will rotate to produce air that will cool the engine. So this is how it looks like. We have the water pump. Water pump is here. We have the thermostat. Thermostat is at that point. We are talking about also the radiator. This is the radiator. This is the radiator cap. This is where we fill the water that is to cool the engine. And then we have the pipes. These are the pipes that will ensure that the water flows from this point to this other point, and this one from to that other point. So remember, the water will be flowing by the normal principle that hot water will be less dense, and therefore the cold water will be denser. So the cold water will move from this point ikikuja huku. So in this case, as it comes this way, it will flow all the way, and after it cools the engine, after it rotates through the water jackets in the engine, it will become hot and therefore become less dense and rise, and again come to the radiator. And now in the radiator we have these what we're calling the fins, and the fan in the other side. It will cool the water again, and the same process continues. Now the cooling process, what happens? The cool water is sucked from the bottom, as I've shown you, and water is pushed through the water jackets and circulates in the engine block. The thermostat will be used to regulate the temperature in the water, and therefore when the water is too hot, it is forced back to the radiator for cooling, and the fan and fin will cool the water. Now The cooling process will occur that way. So this is the radiator cap, the radiator, water will be cooled here, and then we have the hoses. This is the fan, and then these are the radiator hoses. We have the water pump, we have the water jackets. These are the water jackets. So the water jackets are simply connections that will be across the whole engine. Therefore the water will move from this point. This is the cold water, which is denser. It will move to from this point and get all the way up to that point, where it will be pumped to the water jackets, and it will be flowing just like that all through. It will move all through like that, and after it cools the engine, it will become hot and therefore becomes less dense, and it will flow back because it will be less dense. It will flow back upwards, and now it will come back to the radiator for cooling. The fan will rotate, and the fins will increase surface area for cooling of this water here, and therefore the water will cool, and eventually we will have a cooling process in the engine. So that is simply what we look at about the cooling process, and that is all for today. The next time we look at the lubrication system and the power transmission system. I hope you are enjoying your studies at home, and make sure that you do the best in that. Look for questions over the same, and do your revision on the same topic, so that when we come next, we'll look at just the finalization.